Good morning, everyone. Welcome to this capacity building workshop series. This is the Italian one. We will start with the introduction of Water2REturn project. Then we will focus on the market, European and global market, focusing also on legal framework. Then we will focus on the sustainability assessment of Water2REturn system. And then we will focus on the importance of nutrient recycling and fertilizer quality and the regulatory aspects for, of course, Water2REturn system. So, starting with the presentation of Water2REturn, we ask, a lot of persons ask us, why Water2REturn? We start from the need of resources recovery from wastewater effluents. This is widely recognized as a valuable and efficient source of nutrients for the use in agriculture, and also because in the 21st century, agriculture is facing multiple challenges. So, feed of growing population of 9.1 billion people projected in 2050 with a smaller rural labor force, and in a context of climate change, land limitation, and soil degradation. Then we focus also on food industry, especially for the European slaughtering sector. This is characterized by an high water and energy consumption and production of large amounts of waste and wastewater. And then also on the final products of Water2REturn, which are chemical biostimulants. This sector is experiencing an unstoppable increase in demand, and their extensive use is problematic as they are associated with emissions of greenhouse gases, and this can cause an eutrophication if they leach into water bodies, among other environmental problems. We started from the point of the approach of treating slaughtering wastewater. So in spite of all the benefits of adopting a circular economy approach, current practices tend to nutrient removal instead of recovery and recycling. And that's what Water2REturn is doing. We have an alternative, the more sustainable approach compared to the actual treating of wastewater. It faces the environmental and economic constraints of the slaughtering industry as a market opportunity. It aims to adopt a circular economy approach to extract the maximum value from slaughterhouses' effluents, and it makes it also possible to recover nutrients from slaughtering wastewater and turn them into valuable products for the agricultural sector. Water2REturn propose an integrated solution for slaughterhouse wastewater treatment and as well for the recovery of nutrients with high market value in the agricultural sector. This circular economy approach turns wastewater treatment facilities into biorefineries. Our project is an innovation action built on bottom-up approach based on the current market demand co-funded by European Commission under Horizon 2020 program. We started our journey in July 2017 and we will end in this month, March of 2022. Our consortium is made up of 15 partners from 8 countries, and this project is coordinated by BioAsil, which is a technology provider company located in Malaga, Spain. In this slide, you can see the Water2REturn system. We have a water line, a sludge line, an algae line, and also an energy recovery module. With the water line, we recover a secondary raw material, which is a nitrate concentrate. We tried to set up the first agronomic product, which is an organic fertilizer, but we didn't get so much promising results. So we focused on the sludge line and algae line, which make us possible to produce 2 secondary raw material, a nitrolyzed sludge, which will make us able to produce a biostimulant based on Bacillus sp biomass, and another secondary raw material, which is an algae biomass, which will produce the biostimulant based on algae biomass. From the energy recovery module, we will be able to produce biogas plus the CO2 released. We already focused on this aspect, and these 2 agronomic products that are obtained from the production lines I want to remember that they are free of pathogens and heavy metals, and they will be ready for the commercialization at European and international level. And all these agronomic products will be suitable to be used in both conventional and potential organic agriculture. The key innovations of this project is that is a wastewater treatment. It's an integrated system, so it's an integrated system plus nutrients and recovery energy module with 3 separate process units. As I said before, we produce secondary raw material and agronomic products, but also new business model based on circular economy approaches and industrial symbiosis schemes. And this is also a big business opportunity for all the involved sectors, which are the wastewater treatment, the energy engineering and consultancy companies, but also manufacturers of fertilizer, biostimulants, and slaughterhouses and meat industry. We do all these activities with the system that I explained before in Matadero del Sur, which is a slaughterhouse located in Salterras, Seville, and it has a treatment capacity of 50 meter cubes per day. Actually, we are at TRL 767. Here we can see some picture from the Water2REturn demonstrator and the current state of development. Here there is a general overview of water line, sludge line, algae line, and the energy recovery module. And here you can see in particular the water line, the sludge line, the energy recovery module, and the algae line. What are the advantages and challenges of Water2REturn? The advantages is that we produce new business model promoting industrial synergies, and we do an environmental footprint reduction, so wastewater treatment and biostimulant manufacturing and use, plus the creation of green businesses and green jobs. The challenges is that we face the legal framework on the wastewater reuse and bio-based biostimulants, the end-user acceptance, and an economic viability. Our potential clients are the slaughterhouses industry, which are our early adopters, so the meat processing industry. And regarding the bioagronomic products, we are focused on the bioagronomic products distributors and all the agricultural sector, so conventional but also organic farmers. Water2REturn system is a modular system that can be tailored for future clients according to their need and expectation, and it has a high replicability, so it's a flexible system and can be adapted to other food industries. This is the end of our presentation, and here you can see our consortium, which is made by 15 partners from 8 countries. Now I would like to leave the floor to Marco Della Feld from USCBV, who will make a focus on global and the European market of meat market and the legal framework.
Thank you, and welcome to all of you. Yes, this is the reason why we are here in Verona this morning to present the results of our project, because the solution that has been developed during this during the project duration is mainly focused for meat industry and slaughterhouses in particular. And share this kind of information and the benefit of our solution could be an important step in terms of the exploitation of the results of the project. This is an innovation action, so we need to be very close to the market. We need to solve specific market needs. And starting from this input, we have developed in the last 52 months a solution that could be an added value and competitive for the slaughterhouses. So today we are going to see more in details the meat market overview at global and European level, the slaughterhouses legislative framework. In particular, we will show the Matadero del Sur demo sites, and at the end we show the environmental and economic benefit of using Water2REturn solution in the specific application of the slaughterhouses. So like you can see, the forecast of the meat industry value in worldwide between 2020 and 2025 is growing and growing, in particular in the next 3 years. So meat industry play an important role at global level. If we can see the distribution, we can the main production is in the Asia countries. The second is the rest of the world covered the 31% of this production, and the North American cover more or less the 29% of this production. If we focus in terms of revenue of meat products and sausage market worldwide in 2021, the most relevant countries are United States and Germany, and the third one is the Russia. And in any case, the production of meat worldwide from 2026 to 2020 in terms of million metric tons is growing, even if with lower indicators in the last 2 years, due also to the pandemic situation. In order to complete this overview at the global market, we have provided information about the different type of meat, and so pork, poultry, beef, and sheep. And like you can see, the pork play around 25% of this production in the last 5 years, and this forecast is confirmed also for the next years. Again, the per capita consumption of meat at worldwide level see always North American like first countries, and the second is the Oceania, and the third is Europe. So Europe in particular still to play an important role also in meat production. This consumption are growing less than the last year, but in any case we can see that a forecast to 2030. In any case, the consumption is growing in the next year. Just to complete this overview, even if you see a lower consumption at European level for the next year, these values are very small, and so we can confirm more or less the consumption of meat in Europe until 2031. The main relevant nation at European level are Germany, Poland, and France, and Italy, and Spain, of course. So we need to be very focused on this kind of countries. If we focus our attention on the European market, in terms of the consumption, the most important product is the pork, and this is also the reason why our solution is mainly focused on the slaughterhouses and in particular on pork production. This is a very, very important slide that provides you information about the percent of edible meat for human consumption and the percent of inedible meat byproduct. Like you can see, if we speak about poultry and in particular chicken, the percent of edible meat is around 68%. In pig production is 62%. In bovine is 54%, and in sheep goat 52%. If we focus on the pig sector, you can see that we have a 38% of inedible meat, and this is one of the main scope of our project: transform these waste, if we can call waste, into products with an added value. So breeding livestock into generation of waste. However, it's during the slaughterhousing process that most organic solid waste is produced. The amount of solid animal waste will change according to the type of animal slaughtered. Furthermore, in spite of the actual filtration system in place, the solid waste still contain a very high amount of organic and inorganic solid. And the scope of the project is to transform this waste in a secondary raw material, like we have seen before in the general overview of the project. Another important and relative aspect is the regulatory aspect. In fact, we are speaking of water, and we need to. Our solution is completely aligned with the latest regulatory defined by the European Commission and also at national level. In order to make water and secondary raw material products ready for the market, we need to follow this regulatory aspect. In particular, we have analyzed the Water Framework Directive, the Sludge Directive, and the EU Biodiversity Strategy for 2030. In particular, related with the Water Framework Directive, this directive is an EU directive which commits European Union member states to achieve good quality and quantitative status of all water bodies. And we have a document that was written more or less 20 years ago. If we see the second, the Sludge Directive has been adopted 30 years ago, and the new directive is being written with both the needs of the environmental as well the needs of the farmer in mind. And this is a very important point, because for the first time the environmental aspects and the needs of the industry has been taken into account. Regarding the EU Biodiversity Strategy for 2030, is a comprehensive ambition and a long-term plan to protect nature and reserve the degradation of ecosystem, is connected with the Green Deal Farm to Fork strategy defined by the European Commission, and will most likely have a positive effect on the project, and it will increase the use of organic fertilizer with an approach of circular economy. There is a new regulation starting from 2026 of June 2023, in particular related with secondary treatment, filtration, and desalinification. And we are working because our solution is in line also with the regulation that will start in June 2023. So what is the actual situation? The current approach for treating slaughterhouse wastewater, in spite of all recognized benefit of adopting a circular economy approach, current practices tend to nutrients removal instead of recovery and recycling. Without our system, we are developing an approach that it faces an environmental and economic constraint of the slaughterhousing industry as a market opportunity. It aims to adopt a circular economy approach to extract the maximum value from slaughterhouses' effluents, and it made possible to recover nutrients for slaughterhousing wastewater and turn them into value-added products. So what we are doing is to transform waste, and in particular water waste, into products with a value. If we say something in terms of economic KPIs, today the wastewater treatment is a cost, tomorrow the recovery of nutrients and other secondary raw material become a profit for this type of industry. The demo site has been done in Matadero del Sur in Spain on an area of more than 80,000 square meters, 3 slaughterhouses lines, cattle, pigs and sheep goats, cutting and packaging room, a sausage factory and slicing plant. So with this we have tried to cover all the most relevant process in the slaughterhouses industry. The capacity is more or less 50 cube meter per day, and this is a value in line with the an average of slaughterhouses in Europe. And here we are trying to summarize the benefit. For the wastewater treatment, we have an integrated system to treat wastewater while recovering nutrients. In terms of raw material extraction from slaughterhouses, we have 3 different raw material that will be the basis of the agronomic products, and we have agronomic products in terms of biostimulants. Again, we are trying to transform cost in revenues. Again, we have other benefits related with make other fertilizer cheaper, and so add more fertilizer products on the market and in line with the existing legislation. So the solution that we have developed is not only with the actual situation, but also with the regulation that will take into account from 2023. The environmental benefit, with our solution we have reduction of footprint of around 90%. We have a reduction in waste delivery to landfill around the 80%. And we are able to recover nutrients in around 90-95% and fresh water between 20 and 40 in the meat industry. In terms of economic benefits, with the conventional solution, we have a cost of 2.63 euro for each cube meter of water to treat. With our system, we have a cost saving of around 30%, with the final cost of the process of around 1.85%. In terms of business opportunity for the involved sector, for sure, this solution is interesting for wastewater treatment, energy engineering and consultancy company, manufacturer of biostimulants and slaughterhouses, and in general the meat industry. The potential clients, and it also depends to the business model that each future clients want to adopt, are modular system to be tailored for future clients according with their needs and the expectation, and higher replicability because our system is a flexible system. So we have identified potential clients like slaughterhouses industry, the early adopters, in general the meat processing industry, the bioagronomic products distributor, and in particular for the agricultural sector, conventional and organic farmers. So this is a brief overview about the benefit in the meat industry, and in particular for the slaughterhouses. Of course, at the end of the project, more details will be available, so I kindly ask you to follow us on our website and our social media channel, also to see at the end the business plan that provide an overview on the economic solution provided by the Water2REturn solution.
Now I would leave the floor to Daniel Monteleone from ILO, that will focus on the topic of the importance of nutrients recycling and fertilizer quality and the regulatory aspects.
Thank you very much. My name again is Daniel Monteleone from the European Landowners Organization. Let's start with the introduction. So what we're going to discuss today is regulatory aspects of biofertilizers, the importance of organic fertilizer, and environmental benefits of water-to-return projects. So let's start with the regulatory aspects list. INMAP, national policies, European Fertilizer Regulation 2018 and 2019, Farm to Fork Strategy, Sewage Sludge Directive, Water Framework Directive, and EU Biode Strategy for 2030. But as, of course, we spoke with about 3 of those earlier today, we're not going to repeat it for you again. What's INMAP? It stands for the Integrated Nutrient Management Action Plan. The Commission will develop an integrated nutrient management plan with a view to ensuring more sustainable application of nutrients and stimulating the markets for recovered nutrients. The Commission will also consider reviewing directives on wastewater treatment and sewage sludge and will assess natural means of nutrient removal such as algae. Then it's highlighted the key parts. Water2REturn is a project that deals with wastewater treatment and sludge and assesses means of nutrient removal, including algae, which is why INMAP is so important. We actually presented this project to the European Commission last March and advocated for standardization of regulations across the EU instead of 27 different regulations, giving incentives to farmers for using biofertilizers, or as we call it, the carrot, rather than punishing farmers for not using them, the stick, if you will. The next topic, EU Fertilizer Regulation 2018-2019. Goes into effect soon, this year, July 16th. It's changes from 2003. The changes were operating the single market for bio-based fertilizers. It will open the market for new and innovative organic fertilizers by defining the conditions under which these can access the EU single market. It also added rules on safety and quality. The new regulation will provide strict rules on safety, quality, and labeling requirements for all fertilizers to be traded freely across the EU. Producers will need to demonstrate that their products meet those requirements before fixing the CE mark. It will also divide into different categories, which should be each be subject to specific safety and quality regulation requirements adapted to their different intended uses, introducing new limit values for contaminants in fertilizers, and the component materials will be divided, which should each be subject to specific process requirements and control mechanisms. It should be possible to make available on the market an EU fertilizing product composed of several component materials from various material categories, where each material complies with the requirement of the category to which the material belongs. And now moving to the farm to fork strategy. A reduction of nutrient losses by at least 50%, ensuring that there is no deterioration in the soil fertility. This will reduce in the use of fertilizers by at least 20% by 2030, so 8 years from now. This was where the INMAP was actually originally proposed. National policies, since there's 27 different member states, we'll just discuss in general. Nearly every member state has their own rules and restrictions on biofertilizers. When the original legislations were written around the year 2000, they were considered innovative. But now most member states surpass that EU policy. However, with 27 different countries, it becomes difficult to determine what sort of biofertilizers to invest in when the national laws can change at any time. And organic fertilizers. These are substances that are derived from the remains or byproducts of organisms. They're rich in phosphorus, nitrogen, and potassium, but in unequal proportions, as well as 2 types of organic fertilizers. There's a synthetic organic compound produced artificially, for example, urea, and natural. 100% of materials come from nature, for example, manure, compost materials, etc. Examples of these organic fertilizers: cottonseed meal, blood meal, fish emulsion, manure, and sewage sludge. All lovely, beautiful things. Any inorganic material or of wholly or partially synthetic origin that is added to the soil to sustain plant growth, those are inorganic fertilizers. Chemical fertilizers are produced synthetically from inorganic materials. Examples of these: ammonium sulfate, ammonium phosphate, ammonium nitrate, and ammonium chloride. What about the importance of organic fertilizer? Well, it improves its soil structure. Due to the organic matter in the fertilizer, the soil improves its ability to hold onto water and nutrients increase. Microbes thrive. Organic fertilizer is rich in organic matter, naturally helping microbes thrive. Synthetic fertilizer consists of chemical molecules without carbon, which can be disruptive. Avoiding plant damage, some synthetic fertilizers can cause plant damage to both leaves and roots. This is less likely with organic fertilizers. Sustainable and environmentally friendly. Organic fertilizer also increases species diversity by 30% compared with synthetic fertilizer, according to the Organic Trade Association. And it reduces fertilizers and pesticides usage. It can be cost neutral and sometimes a cost savings, as it can reduce the need for pesticides and the overall nitrogen, phosphorus, and potassium requirements, even though it can sometimes be more costly at first. We should address, of course, the negatives of organic fertilizer. Not all products are created equal. Many organic products produce inconsistent results. So make sure you're selecting a product that is industry vetted by reviewing any university studies and/or case studies. Sometimes nutrient levels can be below. The level of nutrients present in an organic fertilizer is often low. So once again, make sure you're looking into what fertilizer exactly you're getting. But environmental benefits, wastewater treatment, integrated system to treat wastewater while recovering nutrients. It's a novel combination of technologies and produces that processes that maximize the extraction of valuable products. It can be customized to the needs of the end users. Other environmental benefits of the Water2REturn project: water materials, raw materials extracted from the slaughterhouse. There will be 3 different raw materials will be the basis of future agronomic products: nitrate, phosphate concentrate, hydrolyzed sludge, and algal biomass. And 3 produced agronomic products: 1 organic fertilizer, 2 biostimulants free of pathogens and pollutants, enhanced nutrient efficiency, abiotic stress tolerance, and/or crop quality traits. I'm not going to spend too much time on this because it was addressed in the previous presentation. But fertilizer, soluble nitrogen and phosphorus, biostimulants, hydrolyzed sludge, and algal biomass. The most important of environmental benefits. These products are free of pathogens, heavy metals, and emergent pollutants. So safe reuse of slaughterhouse wastewater in the EU and abroad. Also, inexpensive, reasonably priced. The process can pay off for the slaughterhouse within approximately 2.5 years. Makes other fertilizers cheaper by adding this process to those that already exist on the market. Will make up 4% of the entire organic fertilizer market, decreasing other fertilizer prices in the long term. In line with all existing legislation, fulfills the increasingly restrictive legislation on agronomic product manufacturing and use. And of course, it comes from an EU project, meaning it's in line with future EU legislation, as EU legislators often look at our existing products and projects on what they're going to do in the future. Once again, Daniel Monteleone from the European Landowners Organization. Also, we mentioned our other social medias, but now on YouTube we have some new videos that explain the process in just 2 minutes. And we recently included a subtitled video in Italian. So we recommend you check it out, also in Spanish, Portuguese, German, French, and of course English as well. Thank you very much and have a great day. And now, introducing our next speaker on the analysis of the life cycle and environmental and social impact of the Water2REturn system, Beatrice.
Thank you. Good morning. I'm Beatrice Bortolozzo from 2B SRL, which is a company based nearby Venice, and we help universities, companies, and we work with the EU and also research centers on their sustainability paths. And the methodologies that we have used in Water2REturn projects are life cycle assessment for the evaluation of the environmental impact, life cycle costing for the evaluation of the economic impact, and social LCA for the social impact. Why these three? Because economic, environmental, and social impacts are the three pillars of sustainability. So that gives you really a 360-degree overview of sustainability. But what is life cycle assessment? Life cycle assessment of the three methodologies is the firstborn, so it has quite some history and it is widely used worldwide. So performing a life cycle assessment of a product or service really means to assess its environmental impact throughout the life cycle. So considering the phases of raw material extraction, production, packaging, transport, use, and end of life. So we would like to give you an example of what it really means to perform a life cycle assessment study, and we consider being here also at Fiera Agricola the life cycle assessment of a milk bottle. So where do I start? How do I do it? In most cases, people think you do start from the cow, but it's a bit more complicated than that. So this is the life cycle. So actually you start from the hay of the feed or the cow, and then you consider its transport either by truck or by boat, and then you get to the farm and you consider the cow, of course, and then the processing of the milk, the bottle, the transportation to the supermarket, the supermarket itself, and then the transport to your home, and the use. Well, in this case, of course, you do not consider the milk, because I might be just drinking the milk out of the fridge, and another person may use it for a recipe, but you do consider the end of life of the bottle. So is that it? Actually, it's even more complicated than that, because when I consider the hay or the feed that I use for my cow, I really have to consider the whole life cycle. So I need to prepare the soil, I need to take care of my plants, so I need water, I need pesticides maybe, and then there is the harvest, and then I do have also a packaging for my feed and my hay, and then it's a whole cycle, so a lot of elements. And in the same way, I need to consider the whole life cycle of my cow. So I need to feed the cow throughout the life cycle. There are costs and there are resources that I use for my cow. But this is also a bit more complicated than that, because the cow is used not only for the milk, but also for meat and also for leather, for example. So I need to allocate the different impacts of the life cycle of my cow to these different outputs. And then I will have to consider also the whole life cycle of the bottle. So the raw materials, and then the production of my bottle, and then my bottle, which is the packaging of my product, will also be packaged in another packaging, which will also have to be considered. And then when my bottle of milk is stored in the fridge at the supermarket, I will have to consider the whole life cycle of that fridge. And then if that fridge contains in its life cycle X number of bottles, I would have to consider that small part of the impact of the fridge that is related to my bottle, and I will have to take that into consideration. And on and on and on. So that is what it means to perform the life cycle assessment of a product or service. So as you've seen, we have, for all the phases of this life cycle, I consider what comes in. So it could be materials, it could be water, energy, all the resources that come in, and all the outputs, which could be waste and emissions to soil, water, and air. And I do get what all the impacts, which could be, climate change, which is very high on the agenda worldwide at the moment, but it could also be water use and ozone depletion, it could be eutrophication, acidification, and then how this translates into damage categories to human health, resource depletion, and ecosystem. So this is the environmental part. This is how the environmental part is structured. When we considered this whole system, these studies, then we have different results for each one study. So for life cycle assessment, the results are, for example, the carbon footprint, as we just saw, the water footprint, or acidification, for example. With life cycle costing, we see the costs. And what is interesting is that if you combine life cycle assessment and life cycle costing, you actually get the eco-efficiency of a product or service. Social LCA is also a methodology that we have considered, and in that case you really see what the impacts are towards the stakeholders involved in the project. So in the methodology that we used, the stakeholders considered are workers, local community users, and small-scale entrepreneurs. So why would anyone want to use these methodologies? What are they for? Well, actually to improve, because when you know what the impacts are, you know where to act. Eco-design, actually life cycle assessment, which is the first one, was really created for eco-design purposes, to start to use it before you even produce a product. These methodologies help you to set priorities, because when you know where the impacts are, and resources are always limited, you don't invest in any kind of impact, but maybe you concentrate on the biggest impacts, on the hotspots. And then it's also important to make comparisons. So when you need to decide between two different processes, for example, of two different materials, there are different aspects that you take into consideration. So the economic aspect, for example, the qualitative aspect, but also the environmental aspects. And this is what it helps you with. And then communication, to avoid greenwashing, so that you can substantiate your communication with scientific information. And then it also helps you to support your path towards sustainable development goals, and also to develop strategies. So you set goals. When you make an assessment, you know what your start point is, and then you can set a goal and then remeasure and see whether you have reached your goals and how to improve. So these three methodologies have been used in the assessment of the Water2REturn project. So what we have done, in the picture on the left, you do see what the Matadero del Sur, which is the slaughterhouse in Salteras in Spain. And so we analyzed the baseline, so the situation before Water2REturn, and then we analyzed the situation, the Water2REturn system, and we analyzed both the construction of the site and the operations. And in the operations, we considered the treatment capacity of 50 cubic meter, which is what the real capacity of this of the site, but also to get a better idea of what would happen in a real case scenario, we also considered a different capacity of 150 cubic meters. And we also considered the agronomic products that come out of this system, which are two biostimulants, and then, well, the idea was to develop this fertilizer, but this is how research goes. Then you research, you try, and then, things can take different directions. In this case, so water is not as rich in nitrogen as expected, but the good thing is that you do not have a fertilizer, which is commercially viable, but you can use this water as a direct fertilizer. So, and we have the two biostimulants which have been taken into consideration with these three assessments. This is just to give you an idea. It's very complex. This is a flow chart of the environmental assessment, just to give you an idea of, it includes all the 4 different lines, the wash line, sludge line, algae line, and energy line, of all the elements that are included and all the different connections. For the social assessment, it's different things. As I mentioned before, there are different stakeholders that can be considered, and within the consortium, after a literature study and focus groups and analysis, we decided to focus on 3 stakeholders. So workers, local community, and users. And how are we doing that? Well, for workers, we check the health and safety, remuneration, discrimination, freedom of association and collective bargaining, and work-life balance. For local community, we considered health and safety, access to material and immaterial resources, community engagement, skill development, and contribution to economic development, and for users, the health and safety. Just to give you an idea of what it means to what kind of results you get with the social LCA, this is actually a database that we use for our studies. We also get, of course, information and data directly, so primary data directly from the consortium, and direct data from the plant. But we also use this database, which is very famous database for social SCA analysis. It's called Social Hotspot database. This refers to the risk of child labor in beef production worldwide. So this is very interesting. It's not related to Water2REturn, but it gives you an idea, for one indicator, which is, very important, well, a crucial one, which is child labor, the risk worldwide. So the risk of child labor for beef production is very high for all the countries that are in dark red. It is high for all the countries that are red. It is medium for the countries in orange. It is low for the countries in green. There is no evidence, actually, of such a risk in all the countries that are in light blue. And there are a couple of countries in gray where there is no data. So that is this is a very nice overview, of what happens worldwide on for this indicator. But coming back to the real situation, this is an overview of the situation before Water2REturn and after Water2REturn. What we can see with life cycle assessment is that there are different adverse effects of nutrient emissions on the environment. So recovery them is, of course, an advantage with Water2REturn. And this is also meeting the requirements of the environmental regulations, which is a big aspect. With life cycle costing, of course, before situation, you have the management cost of waste, sludge, and of wastewater management costs. And with Water2REturn, you have revenues from the agronomic products that come out of the system. With social SCA, in the situation before, because this slaughterhouse is actually not connected to the wastewater treatment of the area, you have a daily transportation of wastewater to the wastewater treatment plant and the management of wastewater. While with the Water2REturn system, of course, you have different effects, because with the use of biostimulants, you need to use less fertilizers, and there are different impacts in the production of biostimulants and fertilizers, both on workers and on the local community. All of this information, so the whole overview of the project, the results, and all the number of the projects will be found in the Layman's report. The Layman's report, together with the website, is really the report that presents in a not too technical way, but still scientifically supported, all the goals and the results, and also who these results are interesting for, of the project. So we are working on that. You can see some of it. It will be available soon, so you can find it on the project website, which is www.water2return.eu. Thank you very much, and have a nice continuation of the meeting.
Thank you, Beatrice, for this presentation. We're at the end of this workshop. I would like to thank all the people that are present here today and all the people that are following us online. I would like to remind to follow us on our website, like Beatrice said before, and on our social channels. And plus, I would like to remind you all that you can fill out a questionnaire that you can find on our website in order to help us in better characterize the water-to-return solution and put it on the market. Thank you once again, and I would like also to remind the next workshop that will be in Madrid, 8 and 9 of March, in the frame of Meet Attraction. Thank you very much.